Greetings and welcome to my new calculus channel. My name is John Gabriel. And today I'm going to be speaking about some of the really peculiar monkey business in mainstream mathematics academics. So let's begin. Now, what happens when the cult of mainstream mathematics academia breaks common sense? What happens? Well, it's very simple. They need to issue new decrees, rules, or executive orders in order to keep their BS afloat. The typical monkey business is what one finds in mainstream mathematics. The typical monkey business that one finds in mainstream mathematics is demonstrated by this well-known video. So this video belongs to someone who has a channel called Just Calculus, and he assumes that this function here initially assumes that it does not have a limit, or rather that he can't determine the limit when x becomes indefinitely large, simply because in his mind, if you put infinity in place of x here, then this becomes large, and so does this, and then you have infinity minus infinity, which according to his father, George Cantor, who's really the father of all mathematical cranks, infinity minus infinity doesn't have an answer. Now, actually, I'll give you a little proof later on to show you that if you use the ill-formed concepts and the delusional ideas of Cantor, infinity minus infinity is actually zero. But that's another, excuse me, that's another story. So he reaches this conclusion, as I said, by trying to find f of infinity, right? And he quickly realizes that the function limit cannot be determined because he knows that infinity minus infinity is not equal to zero, or he doesn't know, he believes that. Okay, he doesn't know anything about it, he just believes it. So then he rationalizes this expression up here, in other words, he multiplies it by 1 and inadvertently changes the expression, which is stated in terms of symbols and not variables, as is commonly believed. So in algebra, you have to be very careful when you do any kinds of arithmetic operations. If you're going to multiply by 1, you cannot be changing the expression in any way. It has to remain the same. You can't change its domain or its range or anything like that. But of course, mainstream academics need to be able to do that kind of monkey business to support their limit theory, as I've stated in other videos. So if we rationalize this expression here and we simplify it, we get this expression, okay? Now one can see that if you plug infinity into x there, that's how mainstream academics think, even though the limit at infinity doesn't mean that at all, but it's actually equivalent to that. Even though the limit at infinity doesn't mean just plugging in x. It literally means f of infinity, okay? In which he undefines f of x in its original form. So how does he undefine x? Let me tell you. So f of 0 is defined here, okay? F of 0 is 0, because this expression is 0, and so is this one. So f of 0 is 0. But in this expression, f of 0 is defined, and it's just a minus b divided by 2, or half of a minus b, right? So he undefines f of x in its original form, but in his dysfunctional brain somehow defines f of infinity. Why? Because now he can go ahead and just plug infinity in there and then follow that other Swiss idiot, Leonhard Euler, and pretend that a of x and b of x are in reality nothing. I'll get to that in a moment. So now the proof that infinity minus infinity is 0 is available at this link here. My video, by the way. Algebra is not as sound as geometry. So for example, when he divides through by x, isn't he in the least concerned that he is dividing by 0? I mean, normally these mainstream crank academics, math academics, are constantly worried about x being 0, especially in the denominator, but they've got no problem doing it here because they simply divide the top by x and the bottom by x, and of course what happens is they put the x into the radical and it becomes x squared, which changes this radical to this, and this radical to this. And then, of course, if you plug in infinity there, then according to delusional mainstream math cranks, this becomes 0, and you have half of a minus b. So now, what did Leonhard Euler do? Well, he wrote a book called The Elements of Algebra. Actually, it's actually a good book, but in some parts it should be called The Elements of Algebra-ish, because it makes no sense at all. So, in Article 82, these are Euler's very own words. He says, to express this idea according to the sense of it above mentioned, we make use of the sign, and he points to the sign of infinity, which consequently indicates a number infinitely great. A number infinitely great? There is no such thing. People, there is no such thing. And we may therefore say that this fraction, well, first of all, this is not a fraction, because a fraction the fraction doesn't consist of non-number objects. This is not a number. So this garbage here that you see in front of you, 1 over infinity, whatever the crap infinity means, I don't know, it's a garbage concept. He says this is in reality nothing. But what he means, it's in reality 0. And then he says, because a fraction cannot be reduced to nothing until the denominator has been increased to infinity. Can you believe it? The guy who wrote one of the best textbooks in algebra actually said a fraction cannot be reduced to nothing until the denominator has been increased to infinity. What an absolute moron. So what he's telling you is this. There exists an n such that 1 over n is equal to 0. Can you find an n that will make this equation here true? You can't. Okay, so if you tell me you can, you're a blithering idiot, because there's nothing that you can put in n here that will make this 0. And you have the same problem when you do stupid things like saying 0.33 is equal to 1, ... is equal to 1, 1/3, and 0.999 ... is equal to 1, and all that other garbage that you have in mainstream mathematics. So continuing from where I left off, the first expression, this here, is not the same as what the presenter did over here. It's not the same as this anymore. He multiplied by 1, but he didn't really do that correctly, because when you multiply by 1, nothing should change. Okay, so in algebra, you can get these anomalies because algebra is not as sound as geometry. Okay, so you have to be very careful when you're working with algebra. It's a very weak form of geometry. In geometry, for example, you can multiply pi and square root 2 and get the result exactly in the form of a magnitude. And you can divide exactly any magnitude. You can do all the 4 operations of arithmetic or any other operations of arithmetic to the precise magnitude. Okay, you cannot do that in algebra. So what he does in his example is equivalent to setting x is equal to infinity once the new expression is obtained. And this same monkey business is found in many limit theory examples. Here's another one. So in this one here, which simplifies to x plus 1 if you cancel out the factor x minus 1, of course you cannot cancel out the factor x minus 1 unless it was understood that this expression here was obtained from this expression by multiplying by x minus 1 over x minus 1, which can only mean 1, okay? It's a constant, the constant 1. So now if f of 1 is equal to 2, when f of x is equal to x plus 1, then f of 1 must still be equal to 2 after f of x is multiplied by 1. You can't punch a hole in the domain of this function here by multiplying it by 1. Do you understand? Okay, and I've gone through that in another video, so I'm not going to harp on it. In his examples, f of infinity, that's really what he's dealing with, is undefined, or in this example. And suddenly it's defined after he multiplies by 1. How'd you like that? That's magic, yeah? Just multiply by 1 and suddenly f of infinity is defined. So while it is correct to say that f of x has a limit a minus b over 2, as you can see from this graph here, I mean, if you actually try to plot this graph, it's not hard to see that you will eventually have a limit of a half, and I'm not going to stay on that. And of course, it's useful to do the sort of thing that is done over here, but it's not really valid arithmetic. It's monkey business, okay? So, now, oh, where was I now? Okay. So, it's correct to say that it has that limit, a minus b over 2, but the arithmetic here suggests that it's fine to think of the limit as that, which works for one form but not for the other, meaning the two forms cannot be the same. So this nonsense happens, again, when mainstream mathematics, who are actually a cult, interpret non-number objects as numbers. In this case, infinity is treated as a number. In this case, 0 is treated as a number. But get this, neither 0 nor infinity are numbers. Neither of those are numbers. So limit theory, as taught in mainstream calculus classes, is a bunch of baloney, okay? And according to the father of all mainstream mathematical cranks, George Cantor, infinity minus infinity equals 0, and the proof is here, okay? Actually, he says the opposite. He said it's indeterminate. And I'm telling you, it's actually determinate. It's equal to 0, according to his bullshit rules. So when mainstream academics break common sense, they need to issue decrees, rules, or executive orders to keep their sinking ship afloat. If you're not already a subscriber, become a subscriber to my channel. I'm infinitely much smarter than you are or anybody else on the planet. I don't care what you think, whether you think I'm arrogant or not. I'm stating fact. I do know better than you or anybody else. So study what I'm telling you very carefully in order that you may become more intelligent, okay? Do not write any garbage in the comment section because it will be deleted and you'll be wasting your time and you'll probably be banned if you persist. My name is John Gabriel and this is New Calculus Channel. Till next time, goodbye.